Hi, I'm Meta Spencer. Today we're going to talk about what is called SAI in the trade. It's short for stratospheric aerosol injection, which is a method of, if you'll excuse the expression, geoengineering. I think that's the term that's most likely understandable to most people, but the language that I am told I should use nowadays is to describe this category of activity as climate repair. And indeed, that's a much more accurate way of characterizing what the whole topic is. We're looking for ways in which the heat that has already been created in the planet's atmosphere can be reduced and returned to levels that were previous, pre-industrial levels. Is that possible to restore the climate to cooler temperatures? Well, that's debatable, and it is constantly being debated in various webinar groups. I belong to two or three. One is called the Healthy Planet Action Coalition or something close to that. And there are two or three others that are mainly the same people all getting together by Zoom who are experts on these topics or hope to become experts, as I belong, but I'm no expert. And they get together and talk about the various issues and problems and challenges involved in trying to establish the usability of these innovations, these technological solutions to global warming. And of course, it's all generally pretty controversial. When we talk about geoengineering at all, the one technology comes out most often as what people probably think of as geoengineering. There are several other things, alternatives that might be preferable and maybe not, but the one that got the most attention and still probably in the most best known of the list is this stratospheric aerosol injection, which is based on the idea that they've seen volcanoes explode and bring down the temperature of the world for a few years by having the emissions from the volcano go up into the stratosphere, and mostly it's sulfur compounds that circle the planet and reflect some of the incoming light from the sun and keep us just a shade or so, maybe 1 degree cooler. And having that experience gives people the idea that we could do that ourselves and cool the planet maybe even more by having planes fly around spraying various compounds or aerosols into the air. And the aerosol is any kind of particle except, I think, water isn't an aerosol, but all kinds of other dust and particles and chemicals that are floating in the air. Those are aerosols. And the one that's most often described as a solution to global warming is the use of sulfur in the stratosphere. So we have this SAI is the topic of our day. Now, I am blessed today by having several people who are active in one of the, or more, several of the webinar groups that I belong to. And therefore, I thought I'd bring them together and we'd have a good conversation. In Britain, in Bath, is John Nissen, who is, I have never had a conversation with him before, but I'm delighted that he's with me. And he's a leader, one of these communities of discourse. Here in Toronto, where I live at my university, the University of Toronto, is Gregory Evans, who is a professor of engineering, and he's an expert on aerosols in general. So whether he's applied that to SAI until now, I don't know, but we're going to find out. And in Australia is Robert Tulip, who had worked in development issues throughout most of his career. He has a background in philosophy, and he's very much engaged with looking for technologies that will help cool the planet. in someplace in New England. You said where'd you say, the Grant, that you are? Where's your location? I've forgotten.
I'm I'm in Vermont.
Vermont. All right, very good. You're in Bernie Sanders territory, right? Good for you. So the Grant is a former Exxon. Is it Exxon executive?
No,
And
no,
he,
no. I was a petroleum engineer in the
yeah.
beginning of my career for only 2 years
Oh,
for
okay.
Exxon.
And then he wound up in California regulating some of these fossil fuel uh, operations. So he's been on both sides of the fence and knows it from that standpoint. And now, finally, I want to introduce Robin Collins, who is, in a way, a newcomer to this community of people, the webinars network. But I've known Robin for 100 years or so. Robin is very engaged with the peace movement in Canada, as I have been for many years. And he is extremely influential and engaged. He spends all his time there doing all these wonderful things, and especially for the Canadian Pugwash Group. So Robin has recently also become interested in and committed to working on uh, climate repair issues. And I'm always very glad when he joins me because he's a very smart man. So I now, having given you a very quick introduction to what this is all about, I wonder, let me have a volunteer. Let's you should all unmute yourselves and be free to interrupt each other as need be to straighten us all out when somebody makes a statement that you would challenge. I want to get a more about 1 minute more of description of what SAI is from somebody who favors it. Which of you, John or Robert or Doug, which of you is most enthusiastic about SAI?
I think I probably am.
All right, good. You're on then. Tell us what it's all about from your pro
Yes.
position, and then we'll maybe find some people who disagrees. We'll see.
Yeah. First of all, a slight pedantic point. The injection is sulfur dioxide, SO2 for short. To go with CO2, I tend to use the SO2, but it's sulfur dioxide. And it.
I'm sorry. Are you saying instead of saying SAI, I should say SA2?
No. The stratospheric aerosol injection is an injection of SO2 in the case of volcanoes. And that
so Meta, you described it as sulfur, and John's pedantic point is that the chemistry of the aerosol is sulfur dioxide.
Oh, okay. All right.
And you inject it as a gas, so it's not an aerosol when you inject it, but it acts as an attractant for water molecules, and then that then forms little tiny droplets of sulfuric acid, which sounds ghastly and dangerous, but it's it's got to be very, very small quantities. To give you some idea, the amount needed to cool the planet by 1 degree could be obtained by taking 10% of current emissions of SO2 into the atmosphere and injecting them into the stratosphere. That's just to give you some idea of the dilution.
Okay. And what exactly is expected to happen after we've injected up there? How much of it do you have to do? How frequently? well, we could get into all the logistics, but the first thing we would notice is immediately cooling effect, or what else would we notice as we walk around on the ground here? Are we going to see something looking different?
Yes. Well, almost certainly the injection will be done by high-flying aircraft.
Mhm.
And they have to fly above the tropopause, which is the boundary between the lower atmosphere and the upper atmosphere. And in that higher atmosphere, called the stratosphere, it's called the stratosphere because it's not at all turbulent. It's very stratified. But it does have a perpetual wind flowing eastwards around the planet, and that can be quite high velocity. But if you inject anything, it gets very quickly spread all the way around the planet at the latitude in which you inject it. Then there's on top of that, a basic movement of the stratosphere. There's what's known as the Brewer-Dobson circulation, which moves the air gradually towards the pole. And so if you inject at 50 degrees north, within a month or two, most of the sulfur dioxide will have left the atmosphere, and that's.
I'm sorry. Where does it go? Wait a minute.
Oh, it just disappears. It just descends into the lower atmosphere.
Okay. Now, stratosphere is considered part of the atmosphere, even though it's thinner, right?
Yeah. So air from the lower atmosphere enters the stratosphere in the tropics and subtropics, and then it exits the stratosphere towards the poles. And that is actually, we can make use of that by injecting it at a fairly high latitude, like 50 degrees north. The stratosphere you inject at that latitude will fall out within a couple of months.
Oh.
Or nearly all of it will have flown out. So because you don't want the SO2 floating around in the Arctic winter, it's quite a good idea to make use of this property, and then you can inject the SO2 in late spring or early summer, and most of the SO2 will have disappeared before the winter, when there's no sun to be reflected. So the SO2 would be doing very little, and perhaps a little bit of negative stuff. It could be actually doing a slight amount of heating.
You've already allayed one of maybe my top concern about it. The only immediate reaction I have to this is that you spray that stuff up there and it'll be a couple of years. And if you find out that there's some negative side effects that you hadn't expected, you can't do anything about it. You just have to wait for it to fall. So now you're telling me that maybe you could do it in a way so that it would be back to normal within a couple of months?
That's right, yeah.
Okay.
Of course, and we know this pretty accurately because we've monitored the SO2 effect of a number of volcanoes at different latitudes, and you can see that the SO2 that goes into the stratosphere has a certain optical density. That's the technical term for how much light it will reflect. But you can measure that from satellites.
Mhm.
And they've monitored the SO2 from volcanoes at there was one at 45 degrees north, and a little bit of the SO2 went south, but almost all of it went north towards the pole.
Mhm.
John,
then
I might jump in with some perspectives on it, if that's all right, Meta.
Yes, please.
The one of the basic concepts here is known as albedo, which is the brightness of the Earth. And what we've seen over the last couple of decades is quite a severe collapse in the brightness of the Earth. That's the amount of sunlight that our planet reflects back to space, and things like the changes in cloud composition, and also the melting of ice and snow, and the increase of soot. They've all made the planet darker, and so the darkening of the world has contributed to the heating of the planet. So on the one hand, you've got greenhouse gases and other warming effects, and then before industrial times, they were all of the warming effects were equally balanced by cooling effects, and so aerosols have a significant cooling effect. So volcanoes especially really cool the planet down, and we've seen a really interesting accidental experiment on how much sulfur dioxide actually does cool the planet just in the last couple of years, when the International Maritime Organization decided from a couple of years ago that they would ban sulfur dioxide in shipping fuel. And that's been identified as one of the main reasons why there's been such a sudden rapid spike in temperature. Like, we used to be masking the warming effect of greenhouse gases by the sulfur dioxide that was added to fuels, and it's also in coal. But by removing that masking, we've seen this sudden increase in temperature, and it's really quite dangerous, because we've seen this sudden spike in temperature that has got all sorts of effects on the melting of the poles and the disruption of the jet stream, and we're seeing it in problems like an increase of extreme weather. So stratospheric aerosol injection, it's I think the way I think of it is like our industrial civilization has been heating the planet up, and we need to have some sort of equal opposite process to balance the heating. What we don't so much need net zero emissions as net zero heating. That is, the cooling of influences that we have need to be in balance with the heating influences in order to stop the planet just going into disruption. And so stratospheric aerosol injection is probably the easiest way that we can cool the planet down. But then there's a whole lot of politics that surrounds it, which is important to understand as well.
Yep,
I can jump in here as well. So certainly, I agree with those descriptions. In theory, the promise of stratospheric aerosol injection looks good. The demonstration from Volcanoes, shows that it can work. I think the devil is in the detail, as we all know, because this is a global scale experiment that we would be considering. And Meta, to your question in terms of the response time or characteristic time, yes, depending on the altitude that ejection occurs in the stratosphere, the particles produced could get removed in a matter of months, depending on how high it is. But there's a number of other what I'll call response times or characteristic times involved. One of the first is, how long will it take for us to be able to see an effect? So do we inject once and we see an effect? Likely not. It would have to be quite a substantial injection at first to really see a large response. It's probably going to have to go on for a period of time, and there the other global cycles, as we see as weather, El Nino, Niña, it's hard to tell when there is a change, let alone a local change going on. And so it's going to be, it's just like you can't average a few days of weather and talk about climate. You can't take just a few measurements and expect that that's going to be representative over the long term. So it's going to take a while to be able to see the response. And then if we start bringing in the things like the global ocean cycles, which are even longer term, there is a question of how much would need to be done and how long it would take for us to know
Hold
it's
on.
working.
You used a word I'm not familiar with. Did you say global poaching cycle?
No, global circulation cycles.
Oh, I beg your pardon. Okay, got
Yeah,
it.
so I mean the point is, as Robert put it, this is an energy balance. The emissions are influencing the energy balance, but we're talking about influencing the energy balance of the planet, and there's all sorts of movements, whether it's weather, whether it's oceans, that are all driven by this energy balance. So getting it right is important. And I think that's some of the other discussion that hopefully will come up today. When will we know, how confident do we have to be before we move to this very, very large scale?
I'd like somebody to swing at that one right away.
Well, so the model suggests
do we know? How much do we know, and how much do we know that we don't know that's important for us to know, that's lacking, that we have to worry about before we dare deploy this thing? And Robert, I'm sorry I interrupted you.
There's a big scientific community who work on these topics. For example, there's the GeoMIP, which is the model intercomparison project, where people make computer models to assess what the effect would be. And what the modelers have worked out is that in order to counterbalance global warming from greenhouse gases, we would need to pretty constantly add about 20 million tons of sulfur dioxide to the atmosphere every year. And if we did that, 20 million tons a year, which when you balance it out over the size of the Earth, it's not enough really to notice. People make these claims, like Mount Pinatubo back in 1991. I quite vividly remember the yellow skies that we had here in Australia from Mount Pinatubo. But the effect of 20 million tons of sulfur dioxide would be very thinly dispersed, so it would be it's not even clear that it would be noticeable at all. But that would be enough to completely counterbalance the warming effect. And it's a bit like an antidote. When you've got a fever, then you need to do something to counteract the fever, or like your Earth has got white blood cells that respond to an infection. And I think of it in a sort of planetary spiritual way, actually. That's the planet Gaia needs to find some antibodies to respond to the disruption that we're causing with heating the planet, and the increasing the albedo is the most immediate way that we can counterbalance the warming effect that we're having. And the warming effect, it's incredibly dangerous. When you look at sea level rise and extreme weather, there's also biodiversity loss. I think one of the big things that people haven't realized is that global warming is quite directly a major cause of extinctions and endangering species. Like, for example, all of the coral reefs of the Earth, if we don't go ahead with stratospheric aerosol injection, then we're not going to have any coral in 50 or 100 years' time, practically, except for tiny bits, like places like the Barrier Reef, Great Barrier Reef. Wonderful biodiversity. won't have it anymore. Amazon rainforest won't have it anymore. We'll have like sea level rise is an incredible danger, and people just don't understand it because Kim Stanley Robinson, he says, what do you think about having a world with no beaches? Because did you know that there's 80 meters or 70 or 80 meters of sea level rise locked up in all of the ice in Antarctica and Greenland? And we just don't know how unstable that might be because we're conducting this incredible experiment with greenhouse gases and just, we're adding 60 gigatons of that, and a gigaton is like a cubic kilometer of water. So we add that's the amount of greenhouse gases that we're adding every year, and it's incredibly disruptive. Now, the idea that we can just sort of suddenly switch off those greenhouse gases, it's just not possible. Like the politics, the economics, the social forces behind greenhouse gases mean we're going to keep on adding that. And the disruption that causes to the planet is just so extreme that it places the stability of our societies and our economies at really high risk. And so if we want to maintain our civilization, then stratospheric aerosol injection is really going to be an essential
my impression, Robert, is that not only everybody on this panel, but most of the viewers will agree with you. Probably not many climate deniers are going to be watching this forum.
So, it's not about climate denial, but sorry, but what we've seen just last week is that there was a big experiment on marine cloud brightening, which is another of the geoengineering technologies on the USS Hornet in San Francisco. And the local council, who are not climate deniers at all, they're people who are very much in favor of cutting emissions in order to stop global warming. But they've put a ban on that experiment because it's mainly the people who are in favor of decarbonizing the economy in order to fix climate change who are the strongest opponents. And that's where the politics is just so very interesting, because those people have been misinformed, and it's getting the information out. Like, I think if people like John Nissen and others were able to get into a mass media debate, then the just providing some of the facts about what's happening in the Arctic, for example, people just not very well informed about these issues, and also that this technology, it's really a very safe technology, and that's something that's just not well understood.
Okay, I think we all, you're right, 100%. Now, the problem is I did not find any opponents to SAI to be on the show. So everybody's going to say I'm stacking the card deck. I'm not being fair to the other point of view. So will somebody be so good as to play the devil's advocate briefly and say what it is that the opponents are, any informed opponent, and there may be a few who are scientists, what they would say is the real worst threat, that the worst case scenario, what might happen as a result of this that we should worry about the most?
Let me ask you a couple of questions. I'm not going to be total devil's advocate because I support the project, but a couple. I mean, I think the one that springs up is chemical contamination as a result of this material coming back into the oceans and so on. So that's one question. That's my first question. I wanted some clarifications on maybe a second and third question. Both are related, and that's on. It's got something to do with the height of the clouds we're talking about, or the height of the material that are in the atmosphere. So when it was mentioned that the International Maritime Authorities had agreed on removing SO2 from oil tankers, and we saw an instant reduction in
All
low,
shipping, not just oil tankers.
right, sorry. Yeah, what I meant was fossil fuel driven shipping. There was an immediate effect on, I guess, low cloud production and therefore deflection of solar radiation. But what we're talking about SAI is stratospheric high cloud insertion of this material, which seems to be different. And I mean, marine cloud brightening is dealing with low clouds as well. So I'd like to get some clarification on, low cloud, high cloud, why soot is a problem for warming, but tanker emissions is not a problem. In fact, it almost sounds like we should get the SO2 back into those tankers because of the urgency of it. So let me start with those two elements. One is the chemical contamination. One is the height of the clouds and the apparent distinction between the good side of SO2 and the bad side of SO2.
Okay, shall
Just swing at that.
okay. Well, as I said, the quantities are quite small, and what's more is when the SO2 droplets, which will be sulfuric acid, descend, they will actually descend in low populated areas, but that it probably not going to be noticeable, and we are, as human beings, quite accustomed to having low levels of sulfur compounds in the atmosphere. For example, if you walk through a wood, there's DMS is emitted by plants, which is a sulfur compound, which actually reacts to form sulfuric acid with water. So we're really quite accustomed to that. So I don't think there's any chemical problem. And the original idea was proposed by Paul Crutzen, who is a laureate, a Nobel laureate in chemistry. So he would have considered that very seriously. The chemical problem that is most often raised is that of ozone depletion. And SO2 could have an effect of depleting the ozone. Now, the ozone reaction is high in the stratosphere, and it's at the end of winter when it's cold. It's unusual, it's because it's a cold reaction. If you inject this SO2 at 45 or 50 degrees north, it will have disappeared before it could affect the ozone reaction. And I'm assured that even if you have a global cooling, so you inject your SO2 at low altitude in the tropics or subtropics, the effect on ozone will be relatively small. So that's a chemistry, I think, that people are most concerned about.
Thank you.
But going on from the chemistry, the biggest concerns that people have are about the politics. That is, that it's possible that you could deploy it. Like, people imagine all sorts of scenarios, and sometimes they're not realistic. But they say, and there's been a couple of books. Kim Stanley Robinson wrote The Ministry for the Future, and there's also Termination Shock by Neil Stephenson. These science fiction books that are just imagining different scenarios. And so termination shock, that means that if we did start injecting sulfur dioxide into the atmosphere, 20 million tons a year, then we need to keep doing it. And because if we stop, then it's masking all of the warming from the excess greenhouse gases that we've got. And so there would be a sudden massive disruption. So it requires that we have a global civilization that people are able to cooperate internationally to enable it. And the view is that people are just too stupid to do that. That we lack the brains to manage a global civilization. But on the other hand, we do have 8 billion people on the planet, and we manage the infrastructure for trade and so on. So in order to maintain our civilization, it's become an essential part of the infrastructure, because we're not going to stop fossil fuels very fast. The estimates are we're going to keep going with fossil fuels at the current rate for 20 or 30 years. And even if we did get to net zero, like there's 1 trillion tons of carbon dioxide that we've added over industrial time, and it's going to take a long time to get that warming effect out of the system. So we really need to do cooling in order to balance the heating. But people think that the scientists aren't smart enough to do the SAI in a way that would be beneficial. So, like, for example, they speculate about the effects on weather in India and Africa. But the way I look at it is that, especially with artificial intelligence, with machine learning, that it's possible to work out when and where and how much of these technologies to use in order to have benefits. And the assessment is that the benefits would far outweigh the potential damage. And it's especially what you need to weigh up is, if we don't go ahead with stratospheric aerosol injection, then we've got the problems of sea level rise and extreme weather and systemic disruption. And those are incredibly dangerous. So David Keith, who's one of the most prominent researchers, he co-wrote.
Oh, David Keith, yes, sorry.
Yeah, he's now.
Let me ask you about your original thesis about, or not yours, but somebody's, that there'd be a shock if you suddenly were doing this on a big scale and then you stopped, that some terrible thing would happen with the. I don't understand that. It seems to me that what would happen is that you just go back to being as if you hadn't been doing it, which is certainly bad enough, but it wouldn't be any worse because of having done it. Is that right? I mean,
you're correct. The danger is that if you have somebody doing the cooling, other people will think, okay, I'm going to put more CO2 into the atmosphere, and that's a kind of psychological risk. And then when you stop the SO2, you've got all that heating from the CO2 that you've added.
That's the moral hazard argument, and I guess we could get into talking about, but moral hazard applies to every kind of climate repair, right? I mean, people who don't want to do it will give the moral hazard argument that it will give people an excuse to keep on emitting greenhouse gas that they wouldn't otherwise do.
There has been psychological research on this very topic. And what they find is that if we decide to do solar geoengineering, it will make people realize that climate change is very serious, and they will actually reduce their CO2 emissions to help. We have the reverse, exactly the reverse moral hazard. The moral hazard is not to do the cooling and risk the catastrophes that will happen if global warming and particularly the Arctic meltdown is allowed to
Well, but
continue.
I do take seriously that the business of trying to orchestrate international cooperation quickly enough and effectively enough to actually implement the damn thing is really the biggest challenge. How will you get people to agree to do this, given the fact they don't even want you to talk to them about experimenting? I mean, international cooperation on something like this has failed. The
I
Paris
think we're quite
Agreement
well.
is not effective, and it's not doing much. And we need something much more powerful. And I think really the question is, if we all agree that it's a good thing to try, or at least we ought to get on with working on it, how do we gin up the activity and get more people fully engaged in trying to promote it?
Well, let me
We're
put
quite
a
well
couple
placed
things
here in
on-
Australia to.
ahead,
Sorry,
Rob.
Greg, you go ahead.
Yeah, I think there's probably three points I'll put forward just to play devil's advocate and stir the table. I would say I am neutral and going past anything other than research on stratospheric aerosol injection. I believe there is a fairly deep chasm that has to be passed to go to the implementation, but I'll get back to that. The rebound or the shock effect, the concern there is that we need global cooperation to design and to implement this, because it would have to be done on a very large scale, like the 20 teragrams per year. And once you're locked in, you have to continue it. And the longer you continue it for, the longer you need to continue it. So we're not talking about global cooperation to implement, we're talking global cooperation to sustain it over decades. And that is just a model that when it comes to a shared interest, it's very different than economic systems where it's individual interest motivates things. Here we're talking about driving something to a shared interest across the planet and seeing that sustained for decades. I would argue, but certainly it's just an argument, that globally we've never achieved that as a species. And so that is one concern. The second concern is in terms of the health side, the actual injection, the SO2, it'll be small compared to what we've done in the past, very small compared to what we were doing in the 1950s when there was a lot more SO2 going in. So I agree with that. The concern there will be the loss of opportunity through decarbonization. At the moment, we have about 8 million mortalities a year due to poor air quality. Almost all of that is due to combustion of fossil fuels. And if we lose that opportunity by, say, going with stratospheric aerosol injection while still continuing to burn all the fossil fuels, all that mortality will continue. And then the last point, just give others a chance to speak, is this progression from doing in-lab computer-based simulation, which is fine. I mean, our computer tools are getting very powerful, but they're not able to do things beyond on average. As soon as it becomes localized at a given time, that's where the uncertainties in the models come in play. So then we need to start doing field tests. You can do some small scale field tests to look at how particles grow, how the SO2 will nucleate to different conditions. But then you need to move to pilot tests. And the question becomes how large a test you need in order to be able to see something happen. Then you get to the design side where you need to have everybody involved, and to the implementation side and the monitoring side. And because the implementation, you can't do it in a small way, because whatever we put up there is going to blow around the planet and it's going to have to be continued. So this is, I cannot think of an analogy of something that we have done as a species on such a large scale with one shot at it. It's very different than other things, infrastructure we put in place where it is localized. We can build it up, scale it up, learn from the process. This is sort of an all-in. And so what level of knowledge will be required to have a social license to be able to implement that, let alone convince everybody else? So
Thank you,
put those
Greg.
3
And
points.
you covered all of the questions that I had about what would a real opponent say. So, and Doug wants to, I'm sure.
Go for it. Yeah.
Doug.
There's a couple of arguments that are made that to me just don't hold water. One is a very simple one, and it comes from the title of a book. And I forget the name of the title actually, but it refers to a milky white sky. And as John mentioned,
Under a
you won't
White
even
Sky by
notice.
Elizabeth Colbert.
Yeah, Elizabeth Colbert. So you won't even notice, as John mentioned, you won't even notice any change in the color of the sky, let alone when there's a little bit of clouds up there already. So the milky white sky is, I think, mainly just a gut reaction that has not been thought out. Another is that, actually I have two more. Another is that it's either or. We definitely must reduce, we must decarbonize. And net zero is not decarbonization. Net zero means you're just drawing down as much as you're spewing out. So that argument, decarbonization is we have to get to zero. Now that, as Robert has said, that's next to impossible. There's going to be some carbon burnt for a number of reasons. So there will always be some drawdown required. That's just a fact of life. We're going to be drawing down just like we're mining gypsum or whatever. It's just another industry. Drawing down carbon is going to have to continue forever if we're going to continue to make plastics, for example, just as an example. So we must decarbonize, and the idea of doing SAI instead of decarbonization is false. We do SAI to buy time so we can get the decarbonization ramped up. We're not going to get it done by 2050. So the SAI is like, as Robert has mentioned before, not in this conversation, but before, it's like a tourniquet or CPR. It's an urgent intervention to keep the patient alive while we get to the point of doing the surgery, the ultimate surgery. So we have to decarbonize. George Woodwell told me in 2009, we must abandon our reliance on the burning of fossil fuels. We're poisoning the planet. That, in a nutshell, is the baseline. So God bless all the people that are trying to do fee and dividend and all the ways to get rid of carbon. It's got to happen. And the last item is, as John mentioned, I'll just reemphasize it. If you do it only in the Arctic, the theory is the Arctic vortex and the jet stream will contain it, and the SO2 will come down into the pole and dissipate onto the ice. It's not going to be global. So it's not going to be from 50 degrees north down to 50 degrees south. It's only going to be north of 50 degrees and south of 50 degrees south. So the idea is not to let it go totally in the initial stages. We may have to get to the mid-latitudes, as they call them. But initially, I think we should start, my personal feeling, we should start with some kind of local experiment in the poles. And somebody might want to respond to that. That's also,
I would say that's the last place we'd want to test it, even though scientifically, I understand completely what you mean, but sociologically, the social license to do testing in the poles in the first place is just not going to happen. So
well, that's true for the northern hemisphere, Greg. Like I think Russia, John, I'll just make this point before I know you want to speak, but like Russia is quite keen on melting the Arctic in order to promote shipping and gas. And with their preoccupation with conquering Ukraine, like it's the last thing on their mind, the idea that we should refreeze the Arctic. And so my view is that it's quite likely that the field experiments that would be needed are more likely to be possible in the southern hemisphere, because so around from 40 to 60 degrees is the Southern Ocean. There's no land, and so it's possible to do to have like a belt that's protecting Antarctica, which is actually melting quite rapidly now. And so if we could show that it works in the Southern Ocean, and if countries like Australia could take a lead, like if we could convince the small island states that are most at risk from sea level rise, that this is a way of protecting them from sea level rise, and that cooling down the Antarctic, it would both be a way of stopping the sea level rise and also reducing the risk of extreme weather, because it's the hot ocean that is the cause of cyclones and hurricanes. John.
Yeah. Okay. So I think we're missing the point that the Arctic is absolutely critical in the Earth system. It is the main way that the planet is kept cold and doesn't overheat, and there is a control mechanism even which involves the Atlantic meridian overturning circulation. That's a bit difficult to explain, but that is actually a kind of control system on the temperature of the planet. And what's happened is that this mechanism has been messed up because we've created a signal into this mechanism to tell it to that the Arctic needs to melt. So that's what's happening, and the result of that is that the Greenland ice sheet is accelerating its melt down, which is contributing to an accelerating sea level rise. The jet stream is affected by rapid Arctic warming. So the jet stream is now sticking badly, increasingly sticking. It's become very lazy in its motion, the wave motion around the planet. And that's causing a lot of weather extremes. So when it sticks in a hot place, that place becomes hotter and hotter as the weather doesn't change. It gets hotter and hotter, and so you get heat domes and weather extremes, and this can make parts of the planet uninhabitable if it occurs in the same place for a few years running. That's wiped out a lot of possibility for safe living. So we've got the great urgency is for refreezing the Arctic, and that will require a lot of cooling power. And stratospheric aerosol injection, one of the main qualities of it is its scalability. By injecting 10 or 20 megatons at 50 degrees north, we can actually reduce the temperature in the Arctic by.
You have to rephrase it. I mean, it's already getting awfully warm. How much potential is there to bring it down to below freezing?
It would have to be continued for some time to bring it down below freezing, possibly 20 years. But then you can gradually phase it out. And if you're lucky, you can actually get a reinforcing effect from the Arctic itself, because once it sees a cooling signal, it amplifies it. Present, it's seeing a warming signal as a result of global warming, and it's amplifying that. So it could work in our favor. And the third thing that is really worrying in the Arctic is the permafrost, which is thawing out, and there's an accelerating amount of methane, and that acts as a feedback, a mutually reinforcing feedback for the warming that's already taking place in the Arctic. and the whole of the Arctic is warming so much that it's now beginning to contribute to the imbalance of energy of the whole planet. So I agree with Robert that we're probably going to have to cool the Antarctic as well. But the real urgency, I can't stress the urgency enough, is for cooling the Arctic. And I have written a letter to the Guardian on Friday or Saturday. I sent it off. So I hope that will be published. But if it isn't, I will be circulating around to everybody to see the argument that I put.
I want to take on the global cooperation issue a little bit, and the related termination shock, so-called. I mean, there are examples that we do have of international cooperation on some issues, like including the maritime shipping issue, including the ozone layer and so on, Montreal Protocol and so on. So it's not impossible. But assuming that some experimentation and low level, well, it might have to be global, but at least at a short scale, can take place to provide evidence that the project works. I don't see an international cooperation problem down the road if it's proven to be working, because it would be quite obvious that the temperature would go back up if you stop doing it over a long period of time. Therefore, there would be no interest in doing that. I mean, Russian shipping notwithstanding. So, which is not a small issue, but I have to assume that the Russians are no different from anybody else, in that the global climate crisis is becoming so obvious that it would affect them as well as everybody else. I mean, they're in the same area of the globe that we are here in Canada, and we are certainly worried about it here. So I don't know that the cooperation problem is a real one, if we have evidence that it works, and that requires the testing at small scale and then larger scale. And if it can be shut off, if it doesn't work, that should provide the confidence. But I mean, who is in the road of the experimentation and the sort of naysaying about global cooperation working?
Well, the opposition is led by Africa. So the recent World Environment Conference in Nairobi, United Nations Environment Agency, Switzerland raised a proposal that the United Nations Environment Programme should do a study of geoengineering. And the opposition to it was led by Africa and by civil society, non-government organizations. And what their argument, so for example, Greta Thunberg, in her book that she edited on climate change, she said that this is just a continuation of the same domineering thinking that got us into the problem in the first place. And so it's an excuse that we can use to avoid the sort of deep cultural change towards justice and equality. And so the African opposition sees it through the lens of colonial politics and imperial politics. And they see it as a sort of imperialist technology from the technocratic West that doesn't recognize the injustice of the world system. So there are really deep systemic issues that lead people to have a very high level of distrust for this technology. One of the ironies is that people imagine that the fossil fuel industry is in favor of geoengineering, but they're really not. They don't provide any money for this research. There's a little bit of money that comes from Bill Gates for the research program at Harvard University, but apart from that, there's no funding. for this work. There was a proposal that the United States government should do a significant research program, and that was rejected last year by the Biden government. So there's a general hostility towards the whole concept, and the main reason for the hostility is the moral hazard argument that we need to get ahead with cutting emissions. But the impracticality of that is something that people just haven't really got their heads around. You know, that it's actually, this issue is marginal to the amount of emissions that we make, because it's mainly economics and politics that and just social inertia. You know, people like cars, and you know, they find, and also people have pointed out that the decarbonisation through wind and solar is actually a lot more difficult than some of its advocates have suggested, and even if we did ramp up wind and solar significantly, it still wouldn't cool the earth. You know, we'd still be in an incredibly unstable climate with a high risk of tipping points. You know, John Nissen mentioned the Atlantic meridional overturning circulation, and the issue is that if the big currents of the world oceans stopped, which they're already slowing down, and if they stopped, then the disruption to agriculture, to food, to the world economy would just be so vast that, you know, the conflict, the disruption would be so extreme. So it's really about just maintaining peace and stability. That's is like their essential values.
I want to give Robin Collins, we're overtime. I want to give Robin Collins the last word, and it has to be not a very long one.
Oh dear. Well, I don't disagree with anything you just said, Robert. I do think that I do think though that we should be backing the decarbonization argument, and loudly, so to deter these people from thinking that we're against decarbonization, because we are arguing. In fact, I don't know anybody in the geoengineering side who is against decarbonization. All we are saying is that while we decarbonize, we must do this because it's so urgent, right? This is a method to allow decarbonization to pick up speed, and so that we can get it done in time. It's not about decarbonization. They're absolutely right about that. This is not about decarbonization. This is about reflection of solar energy while we decarbonize. That's the way we should.
Thank you. And I think that was a good summary from one point of view. I'm sure it hasn't disposed of the others. And Greg gave us a terrific list of all the alternative arguments. But I'm on your side, Robin. And we will be having more conversations about various other technologies for climate repair in the weeks ahead. Every Monday we do this. So thank you all. It's been fascinating, and there's certainly a lot more to be said about this in the future. There's no question about it. We have a lot of work ahead of us. Project Save the World produces these forums. Watch them or listen to them as audio podcasts on our website, tosavetheworld.ca. People share information there about 6 global issues, and we welcome your comments too. To find a particular talk show, check the scroll list on the home page or use the search bar. Project Save the World also produces a quarterly online publication, Peace Magazine, which now serves as a free-of-charge newsletter to help mobilize knowledge about 6 global threats to humankind. We gladly email the magazine as a PDF or link to any interested organization in the world that works to prevent a global catastrophe involving war and weapons, global warming, famine, pandemics, radioactive contamination, or cyber risks. just email us at office@peacemagazine.org, and we'll add your group's email address without charge to our list. Please type "Subscribe my group" as the subject of your email. For individual subscriptions at $20 Canadian per year, go to pressreader.com on your browser and search for Peace Magazine.